An object is traveling in one direction on a straight line. Its distance from some fixed point is given by the table. If we were to draw this situation, we could create an x-axis to show where our object is located at different times. So if I make the 0 of the axis this point, then that would be the start of the motion. So I'm talking about at time 0, the object is located at a position of 0. It looks like 1 second later our object is located at 5 meters from the origin. So we could put it here, and that's going to be the t equals 1 dot, 1 second. After 2 seconds, our object is located at 15. And then after 3 seconds, we're located at 75. These would be like snapshots of where our object is at the 4 given times. In order to calculate average speed for the object, we're going to need the formula average speed equals total distance traveled divided by the time. When you're doing an average quantity, though, you want a time interval to be selected. So they give us that we should do the interval from t equals 0 to t equals 1. So that's going to be these two data points right here. It's going to be from this point to this point. We need to know how far the object had traveled, so that'll be represented by the red here. I'll call that the distance d. And then we also need to know the change in time, and we can find it with a formula. So our distance is going to be final location minus initial location, assuming that the object went straight there. Okay, so our distance is going to be found by subtracting 5 meters minus 0 meters. And then our change in time will be 1 second minus 0 seconds. It does say that the object is traveling in one direction only. That is critical for this kind of problem. Our distance between the points is the distance traveled because the object does not do something like this. If it did that where it went forward and then backward and forward again, the distance could be different than 5 meters. So it is critical that that is stated. Then we're going to have a second distance, which was d2, and then a third distance, which I could call d3. Alright, so that first average speed is going to be 5 meters per second. We can represent this formula a little bit more rigorously with symbols. The formulas which we could use here could be Vs with a bar, which stands for the speed. And we can also give our time interval explicitly by doing this. We want to state the initial time and the final time of the interval. So it would be from t equals 0 seconds to 1 second. And that's going to be 5 meters per second. Our next interval is going to be for the 1 second to 2 second time frame. That's going to be from the green to the blue. So we need to know the d2 of how far it had gone. That's 15 meters minus 5 meters. And we need to know how long it took, so 2 seconds minus 1 second. I get 10 meters over 1 second, so it's 10 meters per second. So this is an object that's a apparently speeding up as time goes on. Because for the first second, it only traveled 5 meters, but then from 1 to 2 seconds, it had traveled twice as far. Okay, lastly, I'll do the final interval from t equals 2 to 3. So our D3 is going to be the 75 minus 15. And we'll divide by 3 minus 2. 60 meters in 1 second. This object is speeding up according to the speed values here. 5 meters per second could be considered relatively slow. 60 meters per second could be considered relatively fast. So we see slow speed at first, fast speed toward the end. When we're making a motion map like this with dots, we can use arrows to qualitatively represent the size of the speeds. So you might show that the speed is slow at the beginning with a short arrow, and then show how it's getting faster and faster, making the arrows longer and longer. So a longer arrow indicates fast speed, whereas a shorter arrow indicates slow speed. This concept is called acceleration when our object has a changing velocity.